All right, welcome Algebra 2. Let's do this. Game plan for today is to solve these rational equations. And for those of you who need more practice, I got you, fam. I noticed that the paper doesn't give us enough space to actually write everything down. It feels very squished. So all I want you to do is just take the paper and, grab your binder and write the question on a loose leaf paper, right? And what we're going to do is we're going to show the notes nice and neat for it, right? So looking at the first problem over here, notice that there should be two methods that we could use for solving these types of rational equations. Method number one, cross multiply, right? Method number two, make the denominators to be the same. Sharing is caring. What I'm going to do is I'll show each question both ways. So let's take a look at the first question, right? Here we have x minus 2 over x minus 4 equals negative 3 over x. And the first method we're going to show is cross multiply. So then how does this work? What we do is we just go this butterfly effect, right? Shout outs for Wilder for saying that. Here we have this butterfly effect. So what happens is this x minus 4 is going to go with the negative 3, right? It's like this goes over here, so it's going to be negative 3 times x minus 4. And then what will go on the left side of the equation, right? The x is going to go with the x minus 2, so it's x times, right? X times x minus 2. Okay, so the first move we could say, we'll write like steps. And if you want, take your time, be nice and neat. I'm going to say 1, cross multiply. 2, you got this. What would be the next move once we get to this position over here? What would I do? Take your time, right? What would I do? Pause the video and figure this out, right? Let me zoom in a little bit. Right? Remember, x times x is x squared, right? So this is x squared minus 2x equals negative 3x. And what's negative 3 times negative 4 is positive 12. Okay. Now here, once we get to this point, a lot of students get lost. Very sad. They're like, Mister, I have no idea what to do once I get to this point. And the tricky thing is, you have to ask yourself, what type of equation do you see? What is the highest exponent you see? The highest exponent is 2. Anytime you have the highest exponent is 2, we call it a quadratic equation. Now, what is the strategy? And we've done this many times. What is the strategy for solving quadratic equations? You want to get 0 on one side so we can factor, right? So here we want 0. So let's take a look. Notice that if I have the x squared minus 2x over here, like the x squared is here, you want this side to be 0. So then how are you going to make this become 0, right? If I have a negative 3x, let's add the 3x and then add the 3x over here, right? So we're just going to make this right side of the equation, we're going to make it equal to 0. So now I have x squared. What is negative 2x plus 3x, right? This will be just positive 1x equals, this cancels. Okay, so then I have 12. So notice we don't have 0 yet. Okay, let me zoom in and let me change this from unhappy face to happy face because we got this. And then how do I make this 12 become a 0? I say minus 12, minus 12. And notice, can I combine the minus 12 with either the x squared or the x? You cannot. So then you just leave it. It's going to be x squared plus x minus 12 equals 0. So congratulations, you have 0, right? Or one thing I should write is, let's review. The first step was cross multiply, second step was distribute, third step get 0, right? Fourth step, once we have 0, you want to factor. And how does that rhythm of factoring go? I wrote it down over here. What two numbers when I multiply is negative 12, but when I add is positive 1, right? Because the coefficient of this x over here is positive 1. So that's what I want you to do. I want you to think about it. Give me two numbers. You multiply to negative 12, but you add to positive 1. Pause the video and think about it, okay? Pause the video and think about it. Don't just wait for me to write it. Try. Why is it 4 and negative 3? What is 4 times negative 3? It's negative 12. What is 4 minus 3? It's 1. So these are the two numbers. Once you find the two numbers to factor, you draw the line down the middle and you say x plus 4 equals 0. X minus 3 equals 0. Right? And then here you just solve for x. What do you say? You say minus 4 minus 4. Plus 3 plus 3, and then here x equals negative 4, x equals positive 3. And that's it. Let's review. Here, what did we do? We first move, we cross multiplied, right? After we cross multiplied, we distributed. Once we saw that the equation was quadratic, you want to get 0. Once you get 0, you factor. Then you have to solve. Then you solve for x. So it feels very extensive, but we've done this before. We've done this in the past. You've done all of this. You just have to put it all together. So notice that when we did this question, what did we do? We did the idea of cross multiply. Right? And here, when are you allowed to cross multiply? If you have one fraction equal to another fraction. So let's just take a look at our paper over here. Like in this example, you can cross multiply, right? Because I have one fraction equal to another fraction. In this example, you could cross multiply as well, right? What I want you to do is pause the video and try and solve this equation, right? Try and solve this on your own before moving forward, okay? And follow the same steps that I did over here, right? Follow the same steps. It'll be the same format, okay? Pause the video and try. And what I'll do is I'm going to show the answer, but I want you to pause the video and don't copy me, right? Try it on your own. Sorry. -8 and +1. If you have any questions on how I did this, just raise your hand and let me know. Here, going back, when are you allowed to cross multiply? You're only allowed to cross multiply if you have one fraction equal to another fraction, right? So something that looks like this, something that looks like this, right? In this example, you can cross multiply. In this example, you can cross multiply. But when you take a look at this example over here, notice that here you cannot cross multiply. Because here you don't have one fraction equal to another fraction, right? Like if the problem was like this, if it was just like this, then you can cross multiply. But now, because you have this part as well, you cannot. So then the idea is, what do you want to do for method 2? You want to get the denominators to be the same. Okay, we want the denominators to be the same. And why do you want them to be the same? Let's take a look here. And what I could do is let's get a brand new piece of paper. I'm gonna write the problem down. Right? Let's see. What does it say? -5 over 9 plus 4 over x equals 1 over 9x. Right? Here, we want all the denominators to be the same. Oh, my bad. Let me zoom out a little bit and take your time, write this down. This is the original question. This is the steps. We want all the denominators to be the same. Okay. So now notice, what are the denominators? We have a 9, we have an x, and we have a 9x. What can I do to make all the denominators be the same? Notice this has a 9. What is it missing? It's missing this x. So what I'm going to do is I'm going to multiply an x to it. But whatever I do to the bottom, I also do to the top, so I'm going to multiply the top by x. This has an x. What is it missing? It's missing a 9. So I'm going to multiply this by 9 and the top by 9. Notice that this part already has the 9x, so we don't need to do anything to this. And let's see what happens. What is -5? Let me zoom in. What is -5 times x? It's -5x. What about the bottom? This is 9x. Plus, what is 4 times 9? That's 36. Over x times 9 is 9x equals 1 over 9x. Okay. Now, what did we accomplish? All the denominators are the same. Great. Now, here, let's write this down. It's really important. When all the denominators are the same, we can cancel them out. We can cancel them out. You could see me here. What you could say is that, oh wait, it's not gonna work. I want you to see that they're done. Like these denominators, once they're all the same, let them know they are done. Nada más. You just bam, you just cancel them out. You could only do this once the denominators are the same. And then notice, what are you left with? You're just left with what's on top, which is -5x plus 36 equals 1. And then once you have this, you can solve this equation very easily, right? What do? You just minus 36, right? You're just going to get x by itself. And notice that this type of equation isn't quadratic, right? It's not a quadratic equation where the highest exponent is 2. So you don't need to get 0 or anything. You just solve straight. So then I get -5x equals -35. Then I want to get this x by itself, so I divide both sides by -5. X equals 7. Right? And that's it. The key thing is getting the denominators to be the same. You want to cancel them out. And to do that, you have to do this idea that sharing is caring. Let's take a look at another one. It looks something like, let's take a look at this. And let me show you the idea of what you need to do. Here, you want the denominators to be the same, and notice that if this has 4, this is 4x, it looks like you want all the denominators to be a 4x, right? You want the denominators to be 4x. So one thing you can notice is that, and you can write this here, that 1 is equal to 1 over 1. So here, when you see this problem, if I have 1 over 4 plus 2x plus 1 over 4x is equal to 1 over 1. Now, you could do this sharing is caring, right? Because now you want all these denominators to be the same. If this has a 4, what is it missing? It's missing that x. This has everything. This has 4x. And what is this missing? It's missing both. It's missing the whole 4x. So then, once you get to this point, it'll be like here, and then I have x plus 2x plus 1 equals 4x. And then you could solve. And it's the same idea here. What you could do with this 8, what do you think you're going to do with this 8 to make your life nice and easy? Put it over 1. And then make the denominators be the same. Okay. Try. And then when you get the chance, go make sure you finish the Delta Math questions that are similar to these types of problems. You got this.